This is Dr. Ryan Johnson with the course Introduction to Statistics. Today we're covering section 6.1, comparing two groups, categorical response. And so up until now, chapters 1 through 5, we've been dealing with the foundations of how statistics works. And now we're going to get into the details of different situations. So this first situation is when we have two groups with a categorical response. Okay? So, in our data for today, involves a pretty chilling potential serial killer named Kristen Gilbert, who worked as a nurse in the intensive care unit, the ICU, of a hospital in Massachusetts. Over the course of her time there, other nurses came to suspect that she was killing patients by injecting them with heart stimulant, epinephrine. She was eventually arrested and charged with these murders. Part of the evidence presented against Gilbert at her murder trial was a statistical analysis of the 1,641 8-hour shifts during the time that she worked in the ICU. For each of these shifts, the researchers recorded two variables: whether Gilbert worked on the shift and whether at least one patient died during the shift. So, for question 1, identify the observational units in this study. And there's a good hint here. The things that were counted for the sample are the things that are the observational units. So the observational units are the things you're counting when you say, my sample is this big. Okay, now classify each variable as categorical or quantitative, whether Gilbert worked on the shift and whether at least one patient died during the shift. So let's review. And then number 3, what variable would you regard as explanatory? Which one is the response? We talked about this a little bit in chapter 5. It's always a good rule of thumb that the one that happened first is explanatory and the one that happened second is response. Now, number 4, is this an observational study or an experiment? Justify your answers. So this should be a full sentence or two, and it's a review of chapter 5. So I'll just move on from there. Okay. Now, so what did the researchers find when they analyzed the 1,641 8-hour shifts? They found that Gilbert worked on 257 of the shifts, and she did not work on 1,384 of them. They also found that a patient died during 74 of the shifts, and no deaths occurred in the other 1,567 shifts. Okay. Now, number 5 is explain why the information in the previous paragraph does not provide any clues about whether there's an association between Gilbert working on a shift and a patient dying during the shift. What additional information do you need to know? Okay, so just giving you, if we're just given the total of each individual individually, but we're not given the I don't want to answer it for you, but a good word to use if you want to sound fancy is cross-tabulation. Make sure you answer number 5 in a full sentence or 2, or 3, but 1 or 2 should probably do it. Okay, now here's some additional information. Among the 74 shifts during which a patient died, 40 were shifts on which Gilbert worked, and 34 were shifts on which Gilbert did not work. Explain why simply comparing only the numbers 40 and 34 is not very informative. So think about this from the perspective of like you are like a detective or maybe a lawyer who's prosecuting Gilbert here. Why would comparing the numbers 40 and 34 not be for your good for your case? What would you want to compare instead? Okay, so then when analyzing data on two categorical variables, a useful first step is to organize the data into a two-way table of counts. In this case, both variables have only 2 categories, so we produce a 2x2 table. So fill in the missing counts in the two-way table below. So you can put your 40 and your 34 would go, here and here, and then, use your calculator to fill in the rest. Okay, suggest a better way to compare the outcomes of the shifts on which Gilbert worked and the shifts on which she did not work than simply comparing 40 to 34. Explain why your answer is more informative. Okay, so that answer should probably relate to the next paragraph about conditional probabilities. Okay, so, or conditional proportions. Okay, that's going to end part one of the videos for this section.